going to study the first theorem from this chapter. The theorem is not having any name, so just to study theorem 10.1, 10th chapter, first theorem, theorem 10.1. Theorem says that the tangent at any point of a circle, tangent at any point of a circle is perpendicular to the radius through the point of contact. What is the statement of the theorem? The tangent at any point of a circle is perpendicular to the radius through the point of contact. So, figure will be like this. What is given? A circle is given. Suppose that circle is having radius O. So, given that a circle having center O and there is a tangent xy is a tangent at the point of contact P. This is given. A circle having center O and xy is a tangent at the point of contact P. Question is, if we join OP, this is the point of contact, this is the center. So, if we join OP, OP is called radius. Why? Because O is the center, P is a point on the circle, so OP is the radius. So, theorem states that this OP radius is always perpendicular to the tangent xy. So, what you have to prove? OP is always perpendicular to the tangent xy. OP radius perpendicular to the tangent xy. Okay. For proving that, mark a point Q on the line xy, on the tangent line xy. Mark a point Q on the tangent line xy. Then join this OQ. Join OQ. So now it is clear that this OQ length, it is greater than OP. Why? Because if this much part is coming outside the circle. Up to here we can tell it is a radius. But this much is bigger. Okay. So OQ is always greater than OP. Why? Because if it is smaller, that Q will be somewhere here. Q somewhere here means XY line will go move like this. So it is a secant, it will not be a tangent. Understood? So OQ is greater than OP. Now you mark a point R here, join, then we will get OR greater than OP. You mark a point S here, join, we will get OS greater than OP. So, for each and every point on the tangent line except P, other line segments are always greater than OP. Understood? In 9th class you studied one result. If you are having a line and an exterior point, from this point we can draw infinite number of line segments to the particular line. From the given point we can draw infinite line segments. But out of that line segments, only one will be perpendicular. Okay, see, if you consider this particular triangle, this is perpendicular I told, and if we consider this line and this line, this is hypotenuse and hypotenuse is bigger. Then if you consider this triangle, this is hypotenuse bigger. If you consider this triangle, this is hypotenuse bigger. Okay. So, which is perpendicular, that will be the shortest line. See, what is the result? From an external point to a line, we can draw infinite line segments. Out of that, only one will be perpendicular, and that will be the shortest line segment. So here what you got? We can mark Q, R, S, T, U, V, so many points, but this will be the shortest one. OP will be the shortest one. So what we can tell, that shortest one will be the perpendicular line segment. Okay, so that is the theorem. In a circle, the tangent at any point is always perpendicular to the radius at the point of contact. So important theorem. You have to write theorem 10.1, draw the figure neatly, and in the textbook that proof is given clearly by seeing the textbook page number 208. Page number 208, the theorem is starting. You take down the theorem and by heart the proof. This is important theorem. Okay, so write the statement, draw figure and write the proof from page number 208. Important theorem.